Hi, my name is Jake Lowe. I'm a software developer at OpenStreetMap US, and I'm here to talk to you about what's new in OSMCha, which is a tool that we maintain. And if you haven't heard of it, OSMCha is a web application. It's at osmcha.org. It's a web app for reviewing and visualizing change sets in OSM. So what's a change set? If you've ever mapped OSM, you probably have made a bunch of edits, and then at the end, you click a button that says save or upload, and you probably type a comment about what you just did. And when you do that, you're changing the map for other people who use the data, but you're also creating a record of your changes that's available for other people to go through later. OSM has a complete history of every change that's ever been made, going all the way back to the beginning of the project, pretty much. And OSMCha is a tool for viewing and dissecting that history to try and understand it, and also to watch the state of the project as it evolves, to detect vandalism, to monitor quality of edits that are coming in. So this is what the interface of OSMCha looks like after you log in. You can see that on the left here, there's a list of change sets. When you log in for the first time, the default will show you all of the recent change sets in the whole world, starting from just a couple of minutes ago. And this is like a live feed, so you load up the website, and it shows you the very latest data. On the right is a visualization of the selected change set. So when you click on any change set in the list, OSMCha renders this graphic on the map. And this is a kind of a data visualization of what that particular change did. Things that were deleted are shown in red, things that were created are shown in green, stuff that was modified is shown in yellow or gray. I'll get into the details of the color scheme in a minute. But this is a really useful tool for looking at what exactly did someone change in this change set and trying to understand the context. Why did they change it? Was their change correct? It shows you details about the change set, like the metadata, the change set comment, who made this change set, what imagery sources they used. If you click on anything on the map, it shows you details about that particular element and what tags were changed, whether the geometry was changed. So you can drill really deep into the details of any particular change set. And also, OSMCha supports filtering. So if you click the filter button up here, you see this interface that lets you filter for change sets by a lot of different criteria. You can select change sets that are in a particular area, like Massachusetts. You can select change sets that touched a particular type of feature, like crosswalks. And you can save that filter and come back to it later, and that when you save it, it becomes available as an RSS feed. So you can even monitor change sets as they're coming in and get a notification anytime someone makes a change in your area of interest or to a feature type that you care about. So OSMCha is used for basically three major purposes. One is people review each other's edits. They watch their local area, they look at what other mappers are touching, and they look over it. They kind of check in on it to make sure that people who are editing the map in their area are editing it accurately. It's also used to automatically detect vandalism and undiscussed mass imports and edits. So OSMCha, when new change sets come into OpenStreetMap, OSMCha runs a bunch of automated filters on them to determine whether they deleted 10,000 elements or whether they added 100,000 new points, suspicious looking signals that indicate that maybe that a human being should go and take a look at that change set. And finally, it's used for kind of history and archaeology to dig into the past of OpenStreetMap and understand, if you see something on the map that you think maybe is wrong, and the last time it was touched was 8 years ago, you can go look at that and figure out why, who made this change, why did they change it, what other stuff did they change at the same time, and get a fuller picture of the context of that edit. So I promised to talk about what's new in OSMCha. So the first thing that's new is a new service that powers the back end of OSMCha. It's called adifs.osmcha.org. This is a website. And to understand what that service is and why it exists, we have to dive a little bit into the technical details of how OSMCha works. So OSMCha, in order to show you the visualizations that you see on the website, it needs complete information about every change set, the old versions of all of the stuff and the new versions, before and after. Because it shows you both things. When on the map, it shows you a dotted line for the old version of the shape of something and a solid line for the new version. When you click on things, it shows you the old tags and the new tags, and it highlights when the tags have changed. And also, I don't know how many people here are deeply familiar with OSM's data model, but there are interesting quirks around it that OSMCha has to understand. In OpenStreetMap, nodes, point features, are the things that have location attached to them. They have a longitude and a latitude. And ways are made up of nodes, but they only reference those nodes by their ID, which means that in order to know the shape of a way, you have to find all the nodes that are part of it. If someone moves one of those nodes, that updates the node, and it creates a new version of that node, and it creates a change set that modifies that node. But the way isn't actually changed, even though if you look at it on the map, its shape is different now. But that way is still version 1. And this is challenging because the OSM API doesn't provide all of that data out of the box. If you download a change set from the OSM API, it tells you what was modified, but it only gives you the new version after the change, and it only gives you objects that were directly modified by the change set. So if you move a node, it doesn't tell you about the ways that that node is part of. And so the solution that OSMCha came to is to build our own augmented diffs. And like the diffs that come from the OpenStreetMap API, these are XML documents, but they contain more data. They contain both the old version and the new version of every element, and they also contain elements that were indirectly affected by the change. This is a format that was devised by the Overpass API. If you use the adiff parameter in an overpass query, it returns the same data format that I'm talking about here. So adiffs.osmcha.org is a new standalone HTTP service for providing these augmented diffs. They are pre-computed by a data pipeline that runs on a server that is part of the OSMCha backend stack. And these diffs are used by OSMCha, but they're also available for other software to use. And our hope is that people will build other tools based on this data. If you're familiar with how OSMCha has worked in the past, this replaces another service that served a similar need called the Real Change Sets S3 service. It makes loading a change set on OSMCha.org much faster than it was before because there were serious reliability problems with the Real Change Sets implementation, which basically meant that data wasn't always available pre-computed, and so it had to be computed on the fly. So most diffs load in under a second now. In the past, it sometimes took 30 or 60 seconds to load a change set. There's a blog post on the OpenStreetMap US blog if you want a lot more technical details on how this service is implemented. But the takeaway that I want to share with you here today is that this service is available for you to build other software on top of. You can ask this service for an augmented diff of any change set, and it will return one to you in XML format that's compatible with lots of other software in the OpenStreetMap ecosystem. So another thing that's new is a package called OSM adiff parser. And this is useful for working with the data that comes from the adiff service. So as I mentioned, those augmented diffs are XML. And in order to use them in a website or a front-end app, you probably have to parse them into JSON or something like that. So OSM adiff parser will take the data that comes from the adiff service and parse it into a JavaScript object that you can manipulate and work with. And this is how OSMCha's front-end deals with these files. There's also a lot of some subtle changes to OSMCha's colors and symbology. And this kind of came along with the migration to the new adiff service because the new data required rewriting all of the map rendering logic. The old data was in a very different format, and the old renderer was tightly coupled to that format. So OSMCha now runs on top of MapLibre, and we rewrote the style sheets to be compatible with MapLibre. Thanks. So we also made some changes to the symbology to make it easier to understand. On the left, you see the before, and on the right, you see the after. The colors are a little bit hard to see in this slide. I apologize. But before, created elements were in green. Old versions of modified elements were in orange. New versions of modified elements were in yellow. And deleted elements were in red. And then there was a purple box around the entire change set. And one of the problems with this was that it doesn't really differentiate between different types of modifications. They're all shown in yellow. And another problem is that the old versions of ways, the new versions of ways, and the relations, which are shown as bounding boxes here, are all shown with solid lines. So it was really hard to tell the difference between these things, especially if you have any kind of color vision deficiency. So the new visualization, created elements are still green. Old versions of modified elements are gray now, to de-emphasize them. New versions are color-coded. So if an element was modified in a way that changed its tags, it's highlighted in yellow. If only the geometry changed, it's in gray. And that's to draw attention to elements that might need review, because generally human reviewers that are looking at a change set are going to want to pay special attention to any tag changes that were made, as opposed to just alignment or geometry changes. Deleted elements are still in red, purple now highlights context elements, which are things that are included in the visualization, not because they changed, but because they're related to something else that changed. So this includes parent ways of nodes that were modified, and child members of relations that were modified. And we use dashed lines consistently for the old versions of everything, solid lines for the new versions of everything, and the relation boxes get their own special dash dot line style to make them easier to see. And this is all implemented by a package called MapLibre ADIF Viewer, which is a plugin for MapLibre that you can use to visualize augmented diffs in this same style in any of your tools if you want to. So MapLibre ADIF Viewer is a plugin for MapLibre. That means you can bring your own MapLibre map, and then you can add this plugin to the map and visualize the augmented diff data of your choice on top of it. And that's available on the OSMCha GitHub as well. The last thing that I'm going to talk about is the OSMCha CLI tool. And this is kind of a proof of concept of why we're starting to extract out pieces of OSMCha. It's so that they can be remixed into other things. OSMCha CLI is a command line tool that you can run in your terminal to view augmented diff data. And to demonstrate how that works, you can download a change set from the ADIF service. Curl is a command that can download data from a web server. You download that change set, and then you pipe it into the OSMCha tool, and it will open up your browser and show you a visualization that looks a lot like the osmcha.org website. That's not that useful or interesting on its own. But the cool thing is that OSMCha, as a command line tool, can visualize augmented diffs that don't come from the ADIF service. You can generate your own augmented diffs, like, for example, from an overpass query, and then visualize those. So I wrote a tool called Overpass CLI that will run an overpass query from the command line. This is just an example of querying to find all of the natural arch nodes in Utah, and it prints out JSON, and you can pipe that into other tools. If you modify the query a little bit to say, specify an area of Boston and specify an ADIF with a time range, so you're asking for the difference from overpass of 2 different points in time for the results of a query, like highways, and then you save that to a file, and then you can pipe that, or you can open that file in the OSMCha command line tool. And what you'll see is a visualization in the style of OSMCha of all of the changes to roads in Boston in the last, I think this was the first 6 months of this year, was the time range we specified. And this is data that came directly from the Overpass API for a custom query and a custom time range. It's not a single change set. It's the aggregation of lots of mappers' change sets over a large period of time. But you can visualize it in the same style. You can click on things and inspect what was changed. So in summary, there's a new augmented diff service that provides augmented diff data for any change set in OpenStreetMap's history. Going back about 6 months, we're backfilling older data. There's updated map visualizations powered by some new packages that have been extracted out into separate modules that you can reuse and remix in interesting new tools, like the command line tool, which you can use to visualize any augmented diff, not just the ones that are provided by the OSMCha ADIF service. So the theme here is trying to make OSMCha faster and more correct, easier and more intuitive for new users, and to pull pieces out of it that do useful things into standalone modules that enable interesting new use cases. So that's all I have for you today. Thanks so much for listening. I just want to end by saying that feedback on OSMCha is really valuable and useful, and I always welcome. Please feel free to file issues on the OSMCha GitHub repository if you run into any problems. We have a Slack channel on the OpenStreetMap US Slack about OSMCha, and I'm not sure if I have any time for questions live, but I think it's time for coffee break, so I will stick around after if anyone has any questions for me. Thanks so much for listening.